Okay, we will discuss that in the last 2-3 minutes of the class. Listen to this. Yesterday I was telling you regarding graphs. Two important points regarding graphs is slope of the graph, how to find out slope of the graph, and how to find out the area under the graph. If you are finding slope, that means you are dividing y with x. And if you are finding area, you are multiplying y with x. Okay. And depending on the relation between the physical quantities, you get different shapes for the graph. It might be a straight line, it might be a parabola, a hyperbola, or a exponentially increasing function. Okay. Now, coming to the physics part, we have to study three types of graphs: displacement time, velocity time, and acceleration time graphs. See, displacement time, velocity time, and acceleration time graphs.
Sir,
Yes.
sir, my doubt is sixth question, sir.
No, we'll discuss that at the end of the class. We are
Okay.
already lagging in the syllabus. Or if you have any doubt, if it is not possible to discuss here, you send that doubt to Rajesh sir. I will answer it.
Sir, this is our last topic, sir.
This is not our last topic. This is our second chapter.
No, sir. In this chapter.
In this chapter, this is last topic.
Okay.
So for different states of motion, what will be the displacement time, velocity time, and acceleration time graphs? See, let us take a body moving with constant velocity. Body moving with constant velocity. Or in other words, the body is in uniform motion. Okay. How will be the displacement time graph for this motion?
Diagonal.
Straight line.
Displacement time graph means displacement on y-axis, time on x-axis. To
Diagonal.
decide the shape of the graph, you should look at the equation which governs the motion of that body. So what equation do you have which gives you displacement or which relates displacement time of a body moving with constant velocity?
Sir, displacement equals
We
to u
have
times.
velocity is equal to displacement by time, or displacement is equal to velocity into time. As velocity is constant, displacement is directly proportional to time. This is like y directly proportional to x. Then the graph will be a straight line like this. So ST graph is a straight line. Okay. Next. What about VT graph? Velocity time graph. Velocity on y-axis, time on x-axis. Velocity time graph. How is the velocity of the body? Constant. Let us imagine a body, a car, something moving in a straight line with constant velocity, some 5 meter per second or 10 meter per second, something. So with time, velocity is remaining constant. So obviously, the graph should be a straight line like this, parallel to time axis. At any instant of time, the value of velocity is same. VT graph is a straight line, horizontal line, parallel to time axis. Next, what about acceleration time graph? What is this motion? Uniform motion or motion with constant velocity. If velocity is constant, acceleration is
Zero.
zero. If acceleration is zero, you don't get any acceleration time graph because there is no acceleration at all. Okay. So
It could
this
be
is
on
for a body
x-axis.
moving with constant velocity. Next, second situation, second state of motion is a body moving with constant acceleration. Constant acceleration. Okay. We want ST graph. We want the shape of ST graph or nature of ST graph. Displacement time. To tell shape of the graph, you should have look at the equation. Which equation gives us the relation between displacement of a body with time and which is moving with constant acceleration?
Sir, kinematic equation 3.
S equal to ut plus half a t square. To make the situation simpler, let us say u is 0. U is 0. Initial velocity is 0. The body is starting from rest. Then S is equal to half a t square. Half a t square. Half is constant. A is constant. Acceleration is constant. That means displacement is directly proportional to t square. This is like y equal to y proportional to x square. Y proportional to x square graph will be a parabola. So this displacement time graph will be like this. Parabolic shape. Next, velocity time graph. Velocity time graph. Which equation gives us the relation between velocity time of a body moving with constant acceleration?
Sir, v equals to u plus 80.
V is equal to u plus 80. Again, if the body is starting from rest, u is 0. So V is equal to 80, or V is
Propor-
directly proportional to T. V directly proportional to T, Y proportional to X. Graph will be a straight line like this. Next, acceleration time graph.
Six
Acceleration on Y
or
axis, time on X axis. How is the acceleration? It is constant. Acceleration is constant with time. It is not changing. At any instant of time, acceleration is same. So the graph will be like this. Third situation. Body moving with constant retardation. Constant retardation. Retardation. Acceleration in opposite direction. That means velocity will be decreasing with time. Displacement time graph. Displacement time graph for constant retardation. S is equal to ut minus half at square. Ut minus half at square. Here we cannot make u 0 because if the body is at rest, how can it get retarded? It will have some initial velocity u moving with constant retardation a. S is equal to ut minus half at square. This is like y equal to ax minus bx square. It is also a equation of a parabola, and the shape of this graph will be like this. Shape of the graph will be like this. It is like inverted of this graph. Inverted graph. Displacement time graph for constantly retarded motion. Velocity time graph. Velocity time graph. Relation between velocity, time, and retardation. V is equal to u minus at. V is equal to u minus at. Here u cannot be made 0. U cannot be made 0. Then you can compare this with y equal to mx plus c.
Intercept.
Compare it this y equal to mx plus c. I will rewrite this equation like v is equal to minus at plus e. In place of m, you have minus a. In place of c, you have u. So slope is negative. Minus a. Slope is negative. Y-intercept is positive. The shape of or the graph will be a straight line, which will be like this. Negative slope, positive y-intercept. Then acceleration time graph. Acceleration time graph for constantly retarded motion. Retarded negative acceleration. So this is plus a, this is minus a. How is this retardation? Constant. Constant means does not change with respect to time, but it is retardation. So negative. We show it like this. Difference is here it is on positive y-axis or positive acceleration axis. Here it is on negative acceleration axis. Suppose a car is getting accelerated by 2 meter per second square. So this value is 2 meter per second square, constant. If the same car is getting retarded, decelerated by 2 meter per second square, then it is here. That's why you are getting the graph below the time axis or on negative acceleration axis. These are basic graphs. Of course, depending on the situation, you get many other graphs also, but these are the basic graphs using which we can draw or we can understand any other graph. The point is, many students can't read graphs. Many students can't read graphs. Problem with those students who don't understand graph is majority of the students. They look at a graph like a photograph. Graph is not a photograph. Photograph shows you the path followed by the body. If you take a photograph of a body which is moving at different instants of time, then that photo or those photos, that set of photos will show you the path followed by the body. But here the graph does not show you how the body or what path the body is taking. It shows you what is the relation between this quantity and this quantity, this quantity and this quantity, this quantity and this quantity. So some students think that if the graph is like this, a straight line, they think that the body is going in a straight line in this direction. This is not the path followed by the body. And if this is the graph, some students think that the body is moving in a curved path. Right? You imagine a car in an open ground and that car is moving in a curved path like this, like this. That is not what we are showing in a graph. As the basic definition of the graph itself says, it is a pictorial representation between the pictorial representation of the relationship between two quantities. If time changes, how does displacement change? That is shown with this graph. How is it changing? At time t equal to 0, displacement is 0. At time t is equal to 1 second, displacement is this much. At time t is equal to 2 seconds, displacement is this much. Time t is equal to 3 seconds, displacement is this much. What does this graph show you? At time t equal to 0, displacement is 0. T is equal to 1 second, displacement is this. T is equal to 2 seconds, displacement is this. 3 seconds, displacement is this. 4 seconds, displacement is this. Here, t is equal to 0, velocity is 0. T is equal to 1 second, this is velocity. T is equal to 2 seconds, this is velocity. 3 seconds, this is velocity. Here, t is equal to 0, this is acceleration. T equal to 1, this is acceleration. T is equal to 2, this is acceleration. It is not at all changing. This is what these motion curves give you, or what they represent. Never think that or never try to understand that graph, the shape of the graph gives you the path followed by the body. Never. It is not the path that we show. It is the relationship between the quantities. Looking at the shape of the graph, you should understand how one quantity is changing with respect to other. In this graph, it is changing linearly. Linearly means if time increases by 1 second, displacement, let us say, increases by 2 meter. Another after 1 second, another 2 meter. Another 1 second, another 2 meter. But here, if time increases by 1 second, displacement is increasing by 2 meter here. Another second, displacement is increasing by 4 meter. Another second, displacement is increasing by 8 meter. Another second, displacement is increasing by 9 meter, like that. This is a non-linear graph. So, variation of displacement with time is faster here than compared to here. And this retarded motion, displacement. What is happening to displacement with time? Is it increasing or decreasing? It is increasing. Displacement is increasing with time, but after a particular certain time, it is becoming constant, because if the body goes with a retardation, its velocity decreases, 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 finally it stops. If it stops, its displacement will be constant, does not change. That's why you are getting this. And here, body moving with retardation, what happens to velocity? Decreases with time. At time t equal to 0, the body is having some initial velocity, let us say 10 meter per second. As time passes, 1 second, 2 second, 3 second, 4 second, 5 second, what is happening to velocity? Decreasing. Finally, at some time, it becomes 0 because the body stops due to retardation. These are the three basic graphs. Okay. Three graphs in three different situations. ST for body moving with constant velocity, body moving with acceleration, body moving with retardation. VT for 3 states, AT for 2 states. Now, what if questions are asked on these graphs, as I told you earlier, I spent yesterday's class only on that point. To extract information from a graph, we use two techniques, either finding the slope of the graph or finding area under the graph. Which method to be applied in which situation? Right. See, suppose if I take uh, I will take a ST graph, this graph. I will take this graph. ST graph for a body moving with constant velocity. It is like this. Okay. Now, if a graph is given to you like this, ST graph, and you are asked to find velocity of the body, some scale will be given here. T is equal to 0, 1, 2, 3, 4, and here some 2, 4, 6, 8, some scale will be given. Using this thing, how can we find velocity from this graph, velocity of the body from this graph? If I give you values, suppose if I tell you that displacement of a body is 10 meter in 4 second time, and if I ask you velocity, you will use the formula velocity equal to displacement by time. 10 by 4, 2.5 meter per second is the velocity. This is numerically okay, but you are not given all these values here. You are given a graph like this, and we want velocity from this graph. We want velocity from this graph. How can we do? Applying basic simple logic, simple basic common sense, we want velocity. And immediately by looking at this graph, you should understand that the body is moving with constant velocity. Then only you'll get the shape of the graph like this. The body is moving with constant velocity. That should strike. Okay. So if the body is moving with constant velocity, what is the formula for velocity? we have only one formula for body moving in uniform motion, which is velocity equal to displacement by time. Okay, displacement by time, right? But we don't have any values, any particular values of displacement and time. Then what can we do? Graphically, displacement by time. This is y, this is x. Graphically, is it y by x or delta y by delta x?
Yes, sir.
What is this delta y by delta x? It is slope. If you
Y2
are
minus
dividing
y1
y
by
with x,
x2 minus
that means
x1.
you are finding slope. You are finding slope. So in simple words, slope of ST graph gives velocity. Slope of ST graph gives velocity. Why? Because velocity is rate of change of displacement, which is delta y by delta x, because we are taking displacement on y axis, time on x axis. Delta s means delta y, delta t means delta x, which is equal to slope. If you find slope, you'll get velocity. Simple. Next, second, if you are given a velocity time graph, the graph is like this. Velocity time graph is like this. Immediately you should understand the body is moving with constant acceleration. That's why, because only then you'll get the graph like this, VT graph. From this, we want acceleration. What is the acceleration? Formula for acceleration is rate of change of velocity, which for graphically here is delta y by delta x, which is again slope. So slope of VT graph gives acceleration. Slope of VT graph gives acceleration because acceleration is delta V by delta T, which is delta Y by delta X from graph, which is nothing but slope. Okay. Slope of ST graph gives velocity. Slope of VT graph gives acceleration. These are not new things. We are not getting any new formula here, any new rule. The same formulas which we already know for velocity and acceleration, we are applying it to graph. That's all. Next, third point. If I take a, I'll take the same VT graph. I'll take the same VT graph, but this time I want displacement from it. I want displacement from it. How can we get displacement? What is the formula for displacement? Relation between displacement, velocity, and time. Displacement
S is
is
equals to V into T.
velocity into time. Displacement is velocity into time. Graphically, here V into T. V into T means Y into X. Y into X means what are you calculating? Indirectly, area. So if you find this area under the VT graph, then you will get displacement of the body. Area under VT graph. area under VT graph gives displacement. Gives displacement. Okay. Fourth point. If I have a let us say AT graph. I have a AT graph. And the AT graph is like this. Body is moving with constant acceleration. Then, if I multiply A with T, what do you get? A into T. Is it velocity? Because acceleration is velocity by time. So velocity will be acceleration into time. Acceleration into time means y into x, which is nothing but again area. This area under the AT graph will give you what? Velocity. So area under AT graph gives velocity. These are the four things, 4 points which you should learn from graphs. 4 points which you should learn from graphs. If you have any doubts in this, you can ask.
Sir, I have one doubt.
Hmm.
Sir, for the first case, sir, could you scroll up? Sir, body moving with constant velocity, acceleration time graph, we can obtain a graph by having it on x-axis, no, sir?
What is the acceleration of a body moving with constant velocity?
Zero, sir.
Then how, even if you'll go on plotting the time, that's all. You'll not get any acceleration on y-axis.
Okay, sir. Like we could represent it on graph, no, sir?
What you have got nothing to represent on graph because A is always 0. If some quantity changes with some other quantity or there is some definite relation among them, we can show that on graph.
Okay, sir.
Now, if you understand these things, let me give you one question. The figure shows displacement time graph of a particle moving on x-axis. Displacement time graph. If you get any question on graph, the first point that you should observe, that you should understand is what quantity is taken on x-axis and what quantity is taken on y-axis. Then you look at the shape of the graph. So this is displacement time graph. Displacement time graph. And how is the displacement changing with time? From here to here, that means from time 0, t is equal to 0 to t naught. T is equal to 0 to t naught. How is the displacement changing? Linearly. Then what will be how will be the body moving?
Sir, constant velocity, sir.
The body will be moving with constant velocity here. Yes, constant velocity from t equal to 0 to t equal to t naught. Then after t naught, what is happening? It is becoming horizontal.
Rest,
Then,
sir.
then don't think that don't think that the body starts from this point. It goes along this direction in this line. Then it is taking a turn and traveling along this direction. No,
It's not
not that.
doing anything, sir, because zero displacement.
Uh, Not zero displacement, constant displacement. From here to here, it is moving with constant velocity. That means its displacement is something here. Let us say it is some 10 meter. 10 meter. After t naught, after time t naught, what is happening to this displacement? It is not changing with time. It is not changing with time. So the displacement is not changing with time. Then what does that means? The body is stopping. It is coming to rest after time. At time t naught, it is coming to rest. Okay. Now, first option is the particle is continuously going in positive x direction. Continuously going. Second point, the particle is at rest. Third, velocity increases up to time t naught and then becomes constant. Fourth, particle moves at constant velocity up to time t naught and then stops. Fourth option is correct. Next.
Sir,
Yes.
sir, up to t0, it is a constant velocity, no, sir.
Yes.
After that, if it stops, then the velocity will again become zero, no, sir.
Yes, velocity will become zero.
Then the line is there straight, no, sir, at the line of 10 meters.
That's what I said. That's why I said don't look at the graph like a photograph. Is this line showing the velocity?
Yes, sir.
Is this line showing the velocity?
No, sir, it's showing displacement.
No, sir. Okay, sir.
Next. An elevator is going up. The variation in velocity of the elevator is as given in the graph. What is the height to which the elevator takes the passengers? Elevator, a lift is moving up. How is it moving? It is given graphically. What is this graph? Velocity time graph. Velocity time graph. Okay. What is happening to velocity? How is it changing? From 0 to 2. Let's say this is in second and this is in meter per second. So from 0 to 2 seconds, velocity is changing like this. What kind of motion is this?
Linear motion, sir.
Don't look at the shape of the line.
Constant acceleration, sir.
How is the body
Constant
moving?
velocity,
0
sir.
to 2
With
seconds.
constant velocity.
Yes, sir. Constant.
If VT graph is like this, then what is
Close to
the
that,
motion?
sir.
Sir, constant acceleration.
Constant
sir.
acceleration, sir.
Constant acceleration.
If AT graph is like this, what does it mean?
Body moving. Sir, constant. Body moving with constant acceleration. Constant acceleration.
This is constant acceleration, this is also constant acceleration. Then what is the difference?
Sir,
Sir, the
first one is
acceleration.
constant velocity, sir. So,
Constant?
first one is zero acceleration. First one is zero acceleration. Next one is constant acceleration.
This one?
Which one, sir? Constant acceleration.
0 to 2 seconds.
Constant acceleration, sir.
This is constant acceleration. VT graph changing with time linearly, velocity is changing. You should understand that velocity is changing with time here. At t equal to 0, v is 0. T is equal to some time, this is v. Some other time, this is v. Some other time, this is v. Velocity is changing with time here. The velocity changes, there will be acceleration. So 0 to 2 seconds, the body is in accelerated motion, constant acceleration. From 2 to 10 seconds, graph is this. What does this mean?
It has constant velocity, sir.
Constant velocity. From 10 to 12 seconds, graph is like this, VT graph. What does this mean?
Retardation.
Body moving with constant
Retardation. From all this, what do we want? Height to which the elevator takes the passenger. Let us say it starts from here and goes to this point. We want this height, which is nothing but displacement. It is nothing but displacement. So ultimately, you have a velocity time graph, and from that velocity time graph, you want displacement. What do you do? Note
Sir,
number.
area.
Sir, we should. Sir, have. Sir, can I tell, sir, Ranveer?
Note number 3. Yes.
Area and a VT graph gives displacement.
Yes, sir.
Area under VT graph gives displacement. Area under VT graph. Now, area under VT graph is this. You can, if you know the formula for area of a trapezium, you can apply directly. Or if you don't know that formula, or if any confusion is there in that trapezium
Height
formula,
is A plus B by 2.
you can divide this graph into 3 parts. This is
Sir,
one triangle.
2 triangles and a rectangle, sir.
This is one rectangle. This is another triangle. So area is equal to area 1 plus area 2 plus area 3. Area 1 is half into base into height. Half into base is 2. Height is 3.6. Plus area 2, length into breadth. What is the length? 10. Is it 10?
8, sir. 8.
10
sir.
minus 2, 8 into what is the breadth?
3.6, sir.
3.6.
3.6, sir.
Plus area 3, half into base into
Half
height.
into 2 into 3 point.
If we add up all these things, we'll get the 2 gone, 2 gone, 3.6 plus 3.6, or it is ultimately 10 into 3.6, right? So 36 meter. "36 meter is the displacement of the elevator. Right. I will send some questions for homework. You solve them before the next class regarding graphs.
Okay, sir.
Okay, sir.
Okay, right. So see you and good night.
Thank you, sir. Bye, sir. Good night, sir. Thank you, sir. Bye, sir. Good night, sir.